Hi, welcome back, Hononegah Honors, Algebra 2. Section 6-7, modeling exponential and logarithmic functions. This is the last section of Chapter 6. So we've been dealing a lot with exponents and logarithmic functions. So you know that 2 points determine a line. Similarly, actually, you can actually need 2 points to determine a curve. So write an exponential function if you are modeling y equals a b to the x. I'm going to give you 2 points here. So I'm giving you an x and a y. So what I'm not giving you in this function is the a and the b. So I know that 10 is equal to ab raised to the first, and I know that 40 is equal to ab raised to the third. And so this is a situation in which we have 2 equations and 2 unknowns. Now, similarly, previously we've done things like substitution and elimination. So I'm going to do this as a substitution question. So what have I divided by b? And so that a would equal 10 over b. And then I'm going to do the same thing over here, and I'm going to solve this one for a. And because I'm trying to find one curve that goes between both of these points, then a in one equation needs to equal a in the other equation. So now I have a situation in which 10 over b would equal 40 over b cubed. Well, this is a proportion, going back to your Algebra 1 days, in which you would cross multiply. Now, here's my helpful hint to you. Always divide by the b with the least exponent, smallest degree. So I'm going to divide by b to the first. And so 10b squared equals 40. Divide by 10. B squared equals 4. And I know I'm running out of room. But b would equal plus and minus 2. Now let's talk just a little bit about that. Technically speaking, exponential functions, we don't have a negative b value. So we're going to go with a positive 2 for the b. So what if I went over here with a positive 2? Well, 10 divided by 2 would equal a would equal 5. So we're saying that y equals 5 times 2 raised to the x would hit both of those functions. Now let's see. Let's actually try this out. So let's go to a graphing calculator. I'm sorry, earlier I didn't tell you that. 5 times 2 raised to the, whoops, I didn't hit the 2 here, so let me see if I can go back. 2 raised to the x power. So there's my curve. And I want to know if it hits the 2 points that it's supposed to. It's supposed to hit 1, 10, and 3, 40. So let's see if I went to my table here and I looked for 1, 10, and 340. And sure enough, it does. It hits both of those. Next, so let's try this again with a word problem. So a store sells basketball hoops. The table shows the number of Y of hoops sold during the X year of the store has been open. Write a function that models the data. So we're talking about an exponential question. So I'm going to use the y equals a b to the x. So I'm going to take 2 of these. So let's say I used 117, and then let's go up here to, and it doesn't matter a little bit, but we're going to go 350. So let's say I use those 2. So 17 for y, 1 for x, 50 for y, 3 for x. Solving for a and solving for a. Setting those 2 equal to each other now. Cross multiply and divide by the smaller b value. So it's b to the first. So I have 17b squared over equals 50. And I'm going to get a decimal here, and that's okay. On your test, I won't make you get a decimal situation, but 50 divided by 7, so using my calculator here in my hand, 50 divided by 17, sorry. And then I'm going to take the square root of that, so square root. And I get 1.715. 5. I round to 3 decimal places. So here we go. I know that B is going to be 1.715. So 17 divided by 1.715. I get B to B, or A to B, sorry, 9.913. So this particular situation, Y equals 9.913 times 1.715 raised to the x. So there's my model. So that's the model that I would use. Now, next one, they want me to actually use a graphing calculator to come up with this. So the one that I've got right now, I'm going to go ahead and write it down over here, is 9.913 times, I'm just writing it down from the previous slide, 1.715 x. We've done this previously. We did this back in, I think it was chapter 2 or chapter 3, in which we're going to use the calculator and we're going to ask it to do a regression equation. So instead of doing a regression equation for a parabola or a regression equation for a line, we're going to actually do a regression equation for an exponent. So let's go to the graphing calculator, and I'm going to go to stats, and I'm going to go to edit, and I'm going to put all the points in. So I'm going to arrow up, hit clear, and then enter. And I'm going to arrow up so I got nothing in my, and I'm going to put all the points from that particular slide. So if you guys want to hit pause and enter the points, I'm going to hit pause and do the same thing. All right, so I'm back. You'll notice that I went ahead and wrote or typed in all the points from the example before. So 117, 231, 350. So if you haven't done that yet, obviously you need to hit pause and catch up with me. I want the calculator. So if you remember right, we did this. We turned our stat plots on. So we went to Y equals, and we went up to plots and hit enter. So the plots were on or highlighted. And then we also went to zoom stats, number 9. So this gave up, notice it makes a nice pretty curve. So I want the calculator to come up just like before when we did a line of best fit. I want an exponential curve of best fit. So I'm going to go back to stats. I want to calculate. And before, again, these are things that we've done previously. We've done the regression lines, and I think we've even done quadratic regression lines. So now we're going down here, and we're looking for an exponential regression line. Hit enter. And so depending on your type of calculators, depending on how many, and so notice A equals B raised to the X. It got 9.648. So 9.648 and 1.747. So I'm going to write those down here on my, oops. So this is the one that's going to come from the calculator, and I'm going to try this again one more time because I forgot it already. 9.648. So 9.648 and 1.747. So you'll notice the two are just slightly different. Like they're not horribly wrong. This one we did by hand, and this one we did using the calculator. And obviously the calculator is much more accurate. Okay, you're using technology to actually come up with it. And I'm going to go back to the calculator because I'm going to show you one more thing. So I'm going to go back to y equals. And if you guys remember, this is back a while, you go to vars, statistics, number 5, equation, and that puts the regression equation in. So if you hit graph, you'll notice that how good this actually hits all the points. So pretty good, like almost right down the middle, except for maybe that top one there. So it's a pretty good regression equation that actually goes to all the points in the equation. Now, it wanted me to make a prediction now. They want to make a prediction in the 8th year. So they want me to put x8 in for x. Well, the calculator will help me with the regression equation. So I hit second in table. I'm just looking for 8, which happens to be right off my screen just a little bit. So 8 is 838.8 or 79. So for this one, 838.79. The other one I'm going to have to do by hand. So 9.913. So I'm going to pull out a calculator. I have one sitting in my hand right now. 9.913 times 1.715 raised to the 8th power. So by hand, now you'll notice even though we were pretty close, like from the one by hand and the one using the calculator, we were pretty close, but the further you go exponentially, the further out that you look, how big a difference we see in our particular model. So 741.85 in comparison to 838.79. So there's a difference there of almost 100, like 90, I'm sorry, 97, okay? And so that can be big. So something that's very small in the beginning and not that far away from each other is huge when you start going exponentially. So the last one we are just going to use a calculator on. The height of a tree increases with the age at the time of planting. The tree is 1 year old. The table shows the heights of the tree at specific ages. Use the graphing calculator to model a logarithmic model this time. So again, I'm not going to make you do a logarithmic one by hand. I'm merely going to make you use a graphing calculator. So we are looking for this function. H is equal to A plus B ln of t, where it represents the data estimate. So we're going to input the data, and then we're actually going to use that model to come up with a particular year. So let's go back to the graphing calculator, and I'm going to type these in. So everybody needs to hit pause, go to your calculator, and type this in. All right, so I'm going to go to my calculator as I just stated to you. And I'm going to type these in. So I'm going to go to Stats, Edit, and you'll notice that I already have it typed in. Now, the little bit of cleanup that you're going to need to do here, because again, you probably just used your calculator in the previous example, you need to clear out what you had previously, and you need to go to Zoom 9, and that will then clear out your previous data and not have your regression line. You'll notice that exponential goes upward. And so I'm going to go back to so I can show this. If I have an exponential curve, it's going to go this way. And if I have a logarithmic curve, it's going to go this way. So as you notice on your graphing calculator, when you graph your points, it's not an exponential curve. It's a logarithmic curve here going from left to right. So I want the calculator to come up with the logarithmic. So I'm going to go to Stats. I'm going to go arrow over to Calculate, and I'm looking for, whoops, let me try this again. Stats, arrow over to Calculate, and I'm going to arrow down, and notice you have some options down here. And what I'm looking for is a linear or a natural logarithmic, LN regression equation. So I'm going to hit Enter there. So notice it's A, B, ln of x. So I've got an A and a B in this case. So the A is 5.309. So I better write that down. 5.309 plus B, 7.817. 7.817 natural log. In this case, natural log T. And there's my H. So there's my model. Now, I want to know when the X, or the T in this case, is 3 years. So I'm going to go back to my equation. For those of you who don't remember, go to Y equals. One more time. Vars. Statistics, number 5. Equation. And hit graph. And it'll show you that I am making a natural log equation. Hit second and table, and I'm looking for 3. So at 3, 13.897. So my answer to this question that I'm going to write, I'm going to estimate the height of my tree when the 3 years old to be 13.897, and this is in feet. This is actually the last lesson of Chapter 7. Your homework assignment tonight is a book assignment. If you have any questions, please make sure that you talk to your teacher, and good luck.